In this introductory lecture on databases, we'll try to answer some of the key points that need to be understood if you have to gain basic knowledge on what a database is. So the first question, as you can see on your screen, is what is a database? You can think of a database as, so I can type it out for you. A database is a collection of interrelated data, having properties which define the data, right? So I can give you an example. If you're planning to collect all the names of the employees, their addresses, and other personal details and stored them at one place, database would be a good option for you, because storing data in a database will help you to access the data in a very simple manner, and it will also help you to work on the data in more attractive ways, which would not be possible if you stored the data in a normal file. Having databases at your disposal will help you to handle the data better, thereby improving your performance as far as data handling is concerned. The next question that comes to mind is, what is a DBMS? So first of all, DBMS stands for Database Management System. And what is this DBMS? It is a software. It is a software tool which is used to manage databases. As I was mentioning while answering what a database is, I told you that it is all about handling the data. It's all about working on the data. It's all about analyzing the data. In order to be able to perform these operations, in order to be able to work with the data in a manner that is best suited for your application, you need to have a DBMS installed at your end. This database management software or this database management system will help you to deal with the data in a better manner, gain insights from it, and thereby allow you to make the most of the data at your disposal. So you can think of a DBMS as a software to handle databases. Next comes a table. What exactly is a table? You can think of a table as a unit of a database. So whenever we are talking about databases, there are various models using which we can implement databases. There are various ways in which databases can be implemented, and these ways are known as models. They are referred to as models of databases. And the most commonly used database model is the relational model. And this relational model talks about something known as a table. A table defines what a database in a relational model looks like. So you can think of a table as a unit. So a table is a unit of data in relational model of databases, right? It is a unit of data in relational model of databases and is made up of rows and columns, as you would find in any other table. Now, having data arranged in terms of rows and columns will help you to handle the data better. Data manipulation, data access, data storage, all these operations become a lot simpler if you have your data in the form of rows and columns. Next comes the question as to what is a record. You can think of a record. So it is a row of data in a table. So a record is simply a row in a table. Like I said, that a table is made up of rows and columns. So a row is referred to as a record. And not only a record, it goes by another very popular name. It is also known as tuple. Some people pronounce this as tuple, others call it tuple. So record, rows, tuples, these refer to the same thing as far as a table in a database is concerned. Next question of interest is, what is an attribute? So what is an attribute? An attribute is a column in a table. So it is a column. It is a column of values. It is a column of values in a table. And it is also known as feature in databases, right? It is also known as a feature in database terminology. So whether we are talking about columns, whether we are talking about attributes, or whether we are talking about features, they are referring to the same thing. The next question that we would like to answer is, what is degree in databases? Again, fairly simple. Degree is nothing but, so degree equals the number of columns in a table, right? Number of columns in a table. What about cardinality? Similarly, cardinality, I hope I got the spelling right. Yeah. So cardinality refers to the number of rows in a table. As simple as that. What about data type? Remember, whenever you're creating tables in a database, as you would have to, because you would take multiple tables and put them together in a database. That is how relational models work. You take multiple tables and you form a database. That is how the relational model of DBMS works. Now, what is a data type in this context? A data type defines the type of data. So it defines the type of data that can be handled by a particular column of a table. As simple as that. For example, I'll give you a few examples. If you're planning to store the attribute called employee name, so let's say you have a table where you're storing employee details such as employee ID, employee name, salary. Now, if you're going to store something like the employee name, what is the type of data that you'll be dealing with? You'll be dealing with string data. You'll be dealing with string data. If you're planning to store the employee salary, you'll be dealing with integer data. If you're planning to store the employee date of birth, you'll be dealing with date data. So these are the various types of data that you can have in a table. And to define the type of data that you have for a particular column of a table, you will be using data types. More on data types later. What is a primary key? A primary key is a collection of one or more columns which uniquely identify every row of a table in a database. So you can think of a primary key as that unique identifier. For example, if I'm storing student data, which would be my primary key? The student roll number, right? If I'm storing details about citizens of a country, let's say India, then the Aadhaar card ID would act as a primary key, because the value of an Aadhaar ID for one citizen will never be the same as another. Since these two values can never be the same, it qualifies to be a primary key. So like this, you can have one column or one feature, or you can have a collection of columns or collection of features which together will help you to uniquely identify every row of a table. Because remember, every row in a table will define one employee if you're storing the employee data. Every row will define one student if you're storing student data in a table. Every row will define one citizen if you're storing citizen data in a table. That is the significance of primary key. What about a query? A query, you can think of a query as a question. So it is a question which is put forward to a database. That is what a query is. For example, you can have employee data stored in a table. A query that you can put forward to a database is, give me the name of the employee who receives the highest salary, or give me the average age of the employees in my marketing department, or give me the number of females who are working in the finance department. So these are fairly common queries that are put forward to a database. And how do you resolve these queries? How do you answer these queries? To answer these queries, we make use of a programming language. We make use of a programming language called SQL. So SQL stands for, so programming language to answer queries from a user posed to a database is known as SQL. So it's often called SQL, or it's also often called SQL. Now let me give you the full forms here. So SQL stands for Structured English Query Language. It has been shortened to SQL over the recent years, and SQL stands for Structured Query Language. The fact that it's framed in English is implied. Okay, that's what SQL is. It helps you to write code which answers the questions which are posed to a database by any user. For example, if you're on Amazon and you're applying a filter on the laptops that you have searched, that okay, I want only those laptops where the price range is between 50,000 to 80,000. So you apply a filter, right? What happens behind the scenes? Behind the scenes, a query is run. Okay, or we say that an SQL code an SQL code is run which allows you to get back that result that you're looking for, that all laptops between 50,000 to 80,000. So all of this is stored, all the product details are stored in a database, and they are fetched from a database by writing code in SQL. So these are the questions that I wanted you to understand before going for the practical demonstration. So I'm just pausing for a moment. You can take a screenshot of this portion. Okay, I'm scrolling down. Again, you can take it for the remaining portion and for the third part, right? Okay, so I hope you have all of it with you. I can do one thing. I can paste the question and answers in the video description. I think that would work fine. Okay. In case I exceed that word limit, which is there for video description, I think it's better if you take the screenshot. So you can just rewind the video and take screenshots accordingly. I'll try my best to fit in the question and answers in the video description. Now I'll just minimize this and let me move over to the demonstration section. So suppose I want to create an employee table. Okay, so what is it that I want to do? I want to create an employee table, and this employee table has, let's say, three attributes: the employee ID, the employee name, and the age. Now I know that the employee ID for every employee will be unique. So what I can do is I can use employee ID as my primary key. So let me go here and say create table. How do I create a table? I say create space table. I open up my first bracket and then I write the name of the attribute. What is the name of the attribute? EID. So that is employee ID. So first you mention the name of the attribute. Then you mention the data type. Remember, just now we spoke about data type. It defines the type of data that will be represented by the attribute. So what is the type of data that employee ID will represent? Let's assume that is going to represent integer data. So we can say integer. We can simply say integer, and within brackets we can specify the size. So what is the highest value, or what is the maximum number of digits that can be present in EID? Let's assume it's 5. Okay, so the highest length or the largest length of an employee ID is of 5 digits. This is an assumption that I'm making. Okay, this is an assumption that I'm making, and if you're looking at it from an examination perspective, All these will be mentioned in the question. For now, just try to understand the syntax. So first you write the name of the attribute, then you write the name of the data type, then you mention the size. One thing about integer data type is the size is optional. That means whether I mention the size or I don't mention the size, it's absolutely fine. My recommendation is mention it. Mention the size. Okay. Another thing is I said that the employee ID can act as a primary key because the employee ID for all employees will be unique. So against this, all I need to do is I can say primary key. If I just say primary key, it's fine. That's it. It will behave as a primary key. That means two employee IDs will never be the same. That means two employees can never have the same employee ID. That makes sense, right? One more thing you must keep in mind is that the SQL syntax that we are writing, like create, table, these are not case sensitive. That means whether I write create table in all caps like I've done here, or I write it in this way, it means the same. Okay, this is my personal preference. I prefer to write the keywords in this way. If you want, you can use lowercase, it doesn't matter. Okay, fine. So that was about your employee ID attribute. Next, I want the employee name. So I can say ename in short. And I need to specify the data type. Now think about it. What will the employee name consist of? The employee name will essentially consist of letters of the alphabet. Now in order to mention a particular attribute to take values from the letters of the alphabet, we can use a data type called varchar. Okay, we can use a data type called varchar. In case varchar does not work for you, you can go for varchar 2. One of them will definitely work. Either you go with varchar or you go with varchar 2, one of them will definitely work. I'm going with varchar, it works here. And let's say the longest name that an employee can have is of 50 letters. Okay, this is my assumption. Again, a lot of it is based on assumption. From an examination perspective, you will be told about all these things. And next I want the age, so I need to give a comma here. Give a comma, I say age, and the age, of course, it has to be an integer. So I'll say integer, and of course nobody can have an age value which is more than 3 digits. So I'm going for a size of 3 for age. Let's add another attribute called salary. So I'll say salary, and I'll specify it to be an integer. And let's say the size I'm giving is 8. Right? 8-digit salaries are fairly common these days. And I need to close off my bracket and give a semicolon. Right? So let's just go through this once again in case you have any confusion. So I'm looking to create a table. I missed one thing. So glad I decided to go through it again because I need to mention the name of the table. So first you say create, give a space, then you say table, and then you have to mention the table name, which I forgot. I'm so sorry. So I'll say the table name is employee, right? And then I open up my first bracket, and within it I specify the attributes one after the other. Whenever we are specifying the attribute, we need to specify the name of the attribute, the data type of the attribute, as well as the size of the attribute. When it comes to integer data type, the size is optional, but I recommend that you mention the size anyway. And if a particular attribute is a primary key, make sure you mention that against the name of the attribute after the size. Then you write the name of the attribute again, which is ename, the data type, the size. The size should be within brackets, give a comma. Then again mention the name of the attribute, the data type, the size, again name of the attribute, data type, and size. And after you're done, don't forget the semicolon. Finally, you can click on this run button. If you do that, this message saying that the program exited with exit code 0 means that your code ran perfectly, right? Your code ran perfectly. Okay. So this was about creating a table. Now, after you have created a table, think about it. What is the next logical thing to do? The next logical thing to do is to insert values into the table. So how do you insert records? Again, fairly simple. There is a command called insert into. So you say insert into, then you mention the name of the table where you want to insert records. So I want to insert it in the table employee, right? Then you open up your brackets, and in the brackets you mention the attributes one after the other. So which is my first attribute? EID. Next attribute is ename. Next attribute is age, and the final attribute is salary. Please make sure that the names of the attributes are exactly the way you have specified while creating the table. Otherwise, you'll get an error. Then you type values, and again within brackets, you mention the values one after the other. So what is the first value that you need to mention? Now, what is the order? The order is the same that you have mentioned here. So if you have mentioned EID first, the first value that you will give will be mapped to EID. Then you have mentioned ename, so the second value that you give will be mapped to ename. The third value that you give in this values list will be mapped to age, and the fourth value that you give will be mapped to salary. So let's say the employee ID or the employee details that I want to insert, that particular employee has an ID of 1, the age is, or let's say the name now, right? After EID is what? The employee name. Let's say the name is, I'm just coming up with a random name. Let's say ABCDEF. Please make sure that whenever you are inserting values for an attribute which has a varchar data type, I repeat this again, whenever you're inserting values for an attribute which has a varchar data type, make sure the value is enclosed within double quotes. Okay, otherwise you'll get an error. This will be followed by what? This will be followed by the age. So let's say the age of the employee is 26 and let's say the salary is 50,000, right? Again, give a semicolon and you can copy this, right? You can copy this and let's insert a few more records. Let's say 5 records and we just have to change the values, right? So let's say employee ID 2, the name of the employee is DEFGHI, age is 36, salary is 40,000. Then let's say it's the third employee, name is PQRSTU, age is 56 or let's say 51, salary is 80,000. Then let's say there's the fourth employee whose name is say MNP RST, age is let's say 34, this is 60,000 is the salary, and employee 5, let's say the same name. Two employees can have the same name, no problem. And as it is, my employee name, my ename attribute is not a primary key, so this will not lead to any error. And let's say the age is, let's say 34. Again, age can also be the same of two employees, no problem. So can be the salary. Let's say receives a salary of 80,000. And if I run this now, let's see what happens. Yep, again I get the message that program exited with exit code 0. Fine. So this works fine, right? Okay, so now after we have inserted values into our table, what we need to do is we need to retrieve some of these values. So let's suppose I want to find out the names of all the employees. I want to find only the names of the employees. So what do? I say select, I give a space, then I mention the name of the attribute where the value is present. So what do I want to find? I want to find the names of the employees. So where is the name of the employee found? The name of the employee is found in the attribute ename. So I can say ename. So select ename from, then I have to mention the name of the table. Which is the name of the table? Employee, from employee, right? And I just want to find the names, right? I want to find all the names. So select name from employee. So the select keyword that you see here will be followed by the attributes that we want. So I want here, in this case, I want only the ename attribute. And I want it from which table? I want it from the employee table, right? So if I just run this, let's see what happens. We get all the results here. We get all the names of the attributes. Makes sense? Okay. What if we don't want only the names, we want the names as well as their salaries. So we want the name of the employee as well as the salary of the employee. So what do? We type select, then we mention the attributes which contain the values that we want. We mention the from keyword and we mention the name of the table on which we are working. So if we run this, just see what happens. We get the names of the employees as well as their salaries. Right? Makes sense? Okay. Now let's say I want all the employees. I want all the details of all the employees. I want all the details. That means employee ID, employee name, age, salary, everything. So you would be probably thinking that we can go for EID. Just mention the names of the attributes one after the other. EID, ename, age, and salary. Will this work? Let's see. Yeah, it works fine. It works fine, not a problem. But there's a catch. If you're looking to print the values of all attributes from a particular table, instead of specifying the attributes one after the other, you can simply say select star, where star means all. Star refers to all the attributes. So if you say select star from employee and if you run it, there you go. You're getting the same result. You're getting the same result like you did last time. So remember this whenever you're looking to print the values of all the attributes. Whenever you're looking to print the values of all the attributes, instead of mentioning the attributes one after the other, you can simply say select star. It works fine. Okay. All right. Let me show you another example. Let's say I want the names of those employees who have an age above 35. I repeat, I want the names of those employees who have an age above 35. So you might be thinking that, okay, select ename from employee. If I run this, let's see what happens. Okay, I want the name and age, right? So name and age. But I want only those employees with age above 35. So if I run this, okay, I'm getting all the employees, right? This is not what I was looking for. I want to apply some sort of filtering here and extract only this particular employee whose age is above 35, this particular employee whose age is above 35. So in that case, we can use another clause, and that clause is called the where clause. So I can say where. So what is the condition? The condition is the age has to be greater than 35. So where is the age values of an employee stored? It's stored in the attribute age. So I can say where age is greater than 35. So if I run this, let's see what happens. I'm getting only those two employees who have an age above 35, right? I can change this around. So I want all the employees whose I want the names and ages of those employees who are more than 50. So what do I do? Whose age is more than 50. So in the where clause, I specify the attribute on which I want to apply the condition. So in this case, it's age because I want the employees with age more than 50. So I say where age greater than 50. I say age greater than 50. And if I run this, let's see what happens. There you go. I get only one employee, and that is what I should be getting, whose age is more than 50. Makes sense. Okay. What if I want all those employees whose age is less than 30? Then what do I do? Again, age less than 30. Simple. If I run this, what do I get? I get only one employee who's aged below 30. What if I want the name and salary? I want the name and salary. So I would be including the salary here in my list, followed by the select keyword. I want the name and salary of those employees who are getting a salary more than 50,000. So now what will be the condition? Of course, now I'll not be applying the condition on age. I'll be applying it on salary. So I'll say where salary is greater than 50,000. And if I run this, let's see what happens. There you go. I'm getting all those names and salaries where the salary is greater than 50,000. Makes perfect sense. Lastly, I want to show you one more query before we wrap things up. Is that what if I want the name, salary, and age of those employees whose salary is greater than 50,000 and whose age is greater than 50? So in that case, I have two conditions, right? One condition is salary has to be greater than 50,000, and the next condition is age has to be greater than 50. So what do? I have one condition here, salary greater than 50. In order to add another condition, I'll use and. I'll say and then I'll say age greater than 50. So if the salary is more than 50,000 and age is greater than 50, we'll be getting the result. So let's see. Yes. So there's only one employee whose age is more than 50 and salary is more than 50,000. And that is exactly what we get here, right? So if you're having multiple conditions which need to be satisfied, in this case it was so, the salary had to be greater than 50,000, the age also had to be greater than 50. In that case, you'll be using the and, right? What if it would have been the like what if it would have been either one of these? That means either salary is greater than 50,000 or age is greater than 50. In that case, instead of using and, we would go for or. Let's see what happens. There you go. So it's satisfying. If you look at these outputs, it's satisfying either one of those conditions. It is satisfying either one of the conditions, or it's satisfying both the conditions. So in the first example, we see that it's satisfying both the conditions. The salary is more than 50,000, the age is more than 50. In the second case, it's satisfying only one condition. The salary is greater than 50,000. In the third case also, it's satisfying only one condition, because salary is greater than 50,000, but the age is less than 50. Okay, so whenever you have either one of the conditions to be satisfied, you use or. If you have multiple conditions to be satisfied, you use and. Okay, so that was all about introduction to databases. I hope you find this video to be useful. This is a fairly beginner's guide as to how you go about using databases. If you have any queries, please feel free to leave them in the comment section below, and I'll definitely get back to you. Thank you for watching this, and I'll see you in the next one. Bye.